Hello guys, welcome back to Maths on African Motives, still on Mathematics grade 12. In this platform, we shall be focusing on derivatives, applications of derivatives. That's application of derivatives from this question, question number 9 that we're going to focus on as our revision from the question paper, which was written in September 2020 at Eastern Cape. We had a triangle in the diagram below shows triangle ABC drawn such that its vertices lie on a rectangle P. BQS, as shown, PA is equal to SC here, which is equal to TPB 12 and BQ 7 centimeters. Calculate the smallest possible area of ABC. The moment that you are given to calculate the smallest possible area or maximum values, it can be maximum volume, minimum volume, as long it refers to minimum and maximum values. Those are derivatives. That you're supposed to know that the derivative, if you are referring to y and x, the derivative of y with respect to x should be equal to 0, or the first derivative with it should be equal to 0. That's the concept that we are working with. So here, we need to find an expression for area of the triangle ABC. Take note, this is your triangle ABC, which is the shaded region. All right. So what can we do to find the area of this triangle? We can note that there is a rectangle, which is the bigger shape that we had, and the smaller triangle. So we've got this triangle, and this triangle here, APB, ASC, and BQC. These are the three triangles that we have. So if we remove these triangles from the rectangle, we remain with the triangle ABC. All right, so what we need is to find the dimensions so that we can actually have this, because these are right angle triangle. Remember, it's a rectangle. So that means this will be at 90 degrees. This will be at 90 degrees, at 90 degrees, at 90 degrees. Remember the properties of a rectangle. All right. So in order for us to have this triangle, the area of triangle ABC, okay, let's write down here. So we said the area of triangle ABC is going to be the area of the rectangle, the whole rectangle, which is PB, whatever that we have, PBQS. All right. So it's going to be area of rectangle. All right, that's a rectangle, not a square. Rectangle, PB, it was PBQS. All right. Then we subtract the area of the triangle. So if for triangle A, PB, okay, that's A, PB. So we're going to subtract area, triangle APB, minus another triangle here, which is ASC, minus area, triangle ASC, minus area of the remaining triangle, which was BQC. All right. So if we subtract these triangles from the rectangle, we remain with triangle ABC. All right. So what can we do? We need definitely everything, because for the rectangle, everything is going to be fine here. Area of rectangle AB, it's a, all right, it's P, not, I'm now taking here. This is the rectangle P, B, Q, S. All right, that's length times the width. All right, of which we've got the length and the width is there. The length 12, the width is 7. So just multiply 7 by 12 there, or 12 by 7. All right, so if we multiply 12 by 7, what do we obtain here? 12 by 7, that's 84 square centimeters. So we're going to obtain 84. Are they square centimeters? All right, these are centimeters. So it's going to be square centimeters here. All right, so we've got 84 square centimeters, okay? We move on, we calculate the area of triangle AP. This is APB. Knowing that it's a right angle triangle, so definitely we are going to use half base times the perpendicular height. All right, let's check our APB. This is APB. We've got a base T, the height, which is 12. So it's half of 12 times half of T times 12. All right, so this is going to be half times T times 12, which is half of 12, that's 6, guys. So 6 times T, which is 60 square centimeters. Okay, we are done with the area of triangle APB. All right, we move on to the another area. which is area of triangle ABC. Okay, that's ABC. Is it ABC or AC? This is ASC. All right, let's check where do we have our ASC. This is where we have ASC. Here we do not have the length from A to S. We do not have this dimension, but we are given that this is 7. Remember, it's a rectangle, opposite sides are equal. So the whole of this line is 7 centimeters. But from A to P here, we've got T centimeters. So we are going to subtract T from 7. So this one is going to be 7 minus T. So that means our area is going to be half of the base, which is T times 7 minus T. The base T times 7 minus T. All right, so we are going to have half base times perpendicular height, which is half of T times 7 minus T. You can just put it in a bracket. All right, so half of T is same as T over 2. This is same as T over 2 into 7 minus T. All right. So at this stage, we are supposed to definitely expand the brackets. That's T over 2 times 7, which is 7 over 2T. T over 2 times minus T, that's minus 1 over 2T squared, or minus T squared over 2. All right, so this is the area of triangle ASC. We move on. We need the area of triangle, the last triangle, which is a BQC. So we are going to find area of triangle BQC, which is the still same way, half base times the perpendicular height. So where is the base, the perpendicular height? All right, if we have to check the triangle BQC, we are only having 7. We do not have the dimension from C to Q. Just like what we did from the previous way, we know that the whole of this line is actually 12 centimeters. So to find from C to Q, we are going to subtract this T from 12. So it is going to be 12 minus T. So that means we have got 12 minus T and 7. So these are the sides that you're going to multiply, 12 minus T and 7. All right, so this is going to be half of 7 times 12 minus T, or half of 12 minus T times 7, whatever way that you want to write it. Half of 7, that's 7 over 2. Okay, guys, you can even use your calculator. Half of 7, that's 1 over 2 times 7, like that, which is 7 over 2 into 12 minus T. All right, so 7 over 2 times 12, what are we going to obtain? 7 over 2, we multiply by 12. That is going to be 42. So we've got 42 minus 7 over 2 times minus T, that's 7 over 2T. All right. So we have the values of all the areas, the expressions for the areas. So what are you going to do is to combine this area. Remember, we need to find the area of the bigger of that triangle that we have. So the area of triangle ABC, I'm just going to write that area in terms, because it's in terms of T, so I'm going to write it as AT. Remember, we said it's the area of the rectangle PBQS, which is 84 square centimeters. So it's 84 minus the area of APB, and APB gave us 60. So you're going to subtract 60 minus the area of ACS, which is this one of 7 over 2T minus half T squared. So since it's an expression, that's why I'm opening a bracket. The same thing, you subtract BQC, which is also an expression of 42 minus 7 over 2T. All right, so this is our area in terms of T, and we are going to simplify this area so that we can have a simplified part or answer there. All right, so let's collect like terms. Before that, let's expand brackets by negative. So it's negative times this, which is negative 7 over 2T. Negative and negative, that's positive half T squared. Okay, we move here. Negative times 42, that's negative 42. Negative times negative, that's positive 7 over 2T. All right, so the area with respect to T is going to be half T squared. We do not have any other term of T squared. So this is going to remain as half T squared. We move on to the terms with T. Okay, this is negative 6. This is negative 7 over 2T. This is 7 over, okay, the negative 7 over 2t and the positive 7 over 2t, this will actually cancel. These are like terms. The other one is a negative, the other one is a positive. So they will cancel. You remain with negative 6t. All right, you move on to the numbers. We've got 84 here and 42. As you can see, 84 minus 42, that is 42. So this is going to be positive 42. So this is our expression of area. Take note, guys, this is the expression representing the area. But we are given that which consideration is going to give us the smallest, take note here, the smallest possible area. That's the way we are now going to apply our derivatives. Remember what I told you guys when we started, that when it is a minimum, the first derivative should be equal to 0. So it means for this area to be minimum, the first derivative of area with respect to t must be equal to 0. Once it is equal to 0, then we have got the smallest possible area that we can have here. So that means we need to find the first derivative of area with respect to t. All right, so what are we going to have here? We drop the exponent, that's 2 times a half, which is 1. 2 times half, guys, that's a 1, or half of 2, that's a 1. So we're going to have 1t. We subtract 1 on 2 here, it just remains as 1. So it will be t to the exponent of 1. Then we've got negative 6t. T is a linear expression, so we're going to have negative 6. 42 is a constant, so definitely the derivative is going to give us a 0. So this is what we have for the first derivative of area. So what are we going to do is to equate this now to 0, because we said the first derivative must be equal to 0. So t minus 6 must be equal to 0. So t is equal to 6. So when t is equal to 6, that's where we are going to have the minimum possible or the smallest possible area when our t is equal to 6. So if we are to check, we have an expression here for the area that we already have. So therefore, our area is going to be given as, we are now substituting the value of t that we got into the expression for the area here. In place of t, we are now substituting the t, which is 6. So this is going to be half of t, which is 6 squared, minus 6 times t, which is 6, plus 42. So this gives us the smallest possible area that we can have, which is half of, all right, so this is half of 6 squared, so it's half by 6 to the exponent of 2, minus 6 times 6, so it's 6 by 6, plus 42. All right, we have got 24. So this is going to be 24 square centimeters. Remember, the units, they were in centimeters, so your area is going to be square centimeters. So that was the consideration, guys, here that you were supposed to have. You're supposed to determine an expression for area in terms of t. After determining the expression for area in terms of t, then we apply the derivative concept to say the first derivative must be equal to 0 for any maximum, for any minimum value. That is the consideration that you're supposed to have or to know. So that's it, guys, on derivatives, applications of derivatives. So you have to work with much patience from your past exam papers and revision that actually can help. So that's it, guys, from Mason African Motives. Till we meet again.